Now more than ever, it's become imperative to monitor the impact of third-party performance on your web applications. This tutorial demonstrates Transaction Perspective's Virtual Pages feature in Kite and My Keynote. Here's what we'll cover. First, we'll look at the background. Why is there a need for virtual pages? We'll take an overview of the physical page to filter to virtual page flow. We'll see an example measurement script in Kite. We'll graph virtual pages in My Keynote. And then we'll do a summary of the advantages. You ought to know that there's a related tutorial which goes into much more detail on exactly how to create the virtual pages in Kite. We call it a 10-minute deep dive. So let's get started. Over the years, web technologies have advanced considerably from basic HTML web pages served by a single server to rich multimedia experiences and full-fledged web-based applications. With the advancement in technology, there have also been changes to how the content is served and integrated on web pages, where most sites now incorporate content coming from multiple sources. Web pages now commonly include third-party content, such as ads, in addition to content served by you, the publisher. Even among publisher-produced content, there may be components of a page that are created by different internal teams and may have a different performance impact on a user's overall web browsing experience. Tracking the performance and availability of all your web content is important, but breaking the content out into logical segments speeds the task and adds clarity. Given that content from multiple sources is becoming more common in web pages, there's a growing challenge to understand the performance impact from various pieces of page content. Without the right tools, it can be difficult to isolate and measure the performance of specific content. For example, if your network operations team is responsible for monitoring the performance of your website, they may wish to address issues related to content created by your company differently than issues related to third-party content. Transaction Perspective Virtual Pages helps to address these issues and report relevant information to help you understand the performance of various page content. Keynote has long provided web monitoring and measurement services. We can report on the performance of web transactions, individual pages within a transaction, and even individual elements within a page. The Virtual Pages feature adds to this functionality by allowing you to intelligently segment page content and report the performance related to these segments of content separately. So let's look at an overview of the flow from physical page to virtual page. Physical page is like any other measurement that Keynote Network provides. With the Virtual Pages feature, we have the ability to take a look at a subset of that page by defining a filter which creates a virtual page. The results are then populated to My Keynote. Perhaps a more detailed example will help. Here you have a physical page, and we've developed filters to focus on the ads, CDN-hosted content, and partner-delivered content. Each of those is creating a separate virtual page. When those virtual pages are reported to My Keynote, they can be alarmed upon, trended, reported, etc. Before we move on to looking at a measurement script in Kite, let's take a moment to look at filters, which is that all-important middle step between the physical page and the virtual page. Filters provide a simple but powerful approach for defining what should appear in that virtual page. The most common condition used is add URL match. So let's take a look at an example script in Kite, the Keynote Internet Testing Environment. This is a script that goes to the eBay homepage and then does a search on iPod Touch 8 GB. We want to focus on that search results page. In particular, we want to know the performance of the content that came from eBay's own servers versus the performance of content that came from elsewhere. The first virtual page has a filter condition which matches domains that are known to be eBay domains. The second virtual page is just doing the inverse, which is that it matches on-page elements that come from anywhere except those eBay domains. Let's take a look at some of our options for defining these match page elements. In this case, we're matching on the entire URL, but we could just as easily break that into parts and look only in the domain, the path, or the object portion of the URL. We can also use regular expressions to more efficiently define broader filters. After adding the virtual actions to your script, you can play the script back to make sure it's behaving as desired. The transaction performance details on the right will show us graphically what's passing through a filter and what's not. Now remember, the step we're concerned with is the number 2, the search results here. And what we see at first is the results for the regular physical measurement. Now let's collapse that and look at the first virtual page, which was eBay content only. Notice that the content from the other domains is grayed out here. That data will not be reported and will not be calculated into the totals for that virtual page. As we scroll down, we can see the eBay content shows up in white. Those rows made it through the filter and will be part of this virtual page, and they'll be part of the totals for this page. Let's collapse that and look at action number 4, which is the virtual page for third-party content. Now we see all of the non-eBay content is showing up in white. That will be reported for that page. That will be included in the totals, the statistics, the performance information for that page. And here we see the eBay content is grayed out. So we know that our virtual page is behaving the way we want it to. Now let's move on and take a look at what we see in my Keynote. We've deployed a copy of our script to the Keynote Global Network, and we've run it for some time. I'm going to create a time history graph. But before I generate that graph, I want to scroll down to the bottom of the page where I can choose transaction pages to focus on. And here what I want to do is choose that physical page, just step 2, and the 2 virtual pages that follow. Those are all I really want to see in this graph. Now I'll go ahead and generate that graph. And here's where it gets really interesting. The blue bar represents the total time for that actual physical page. The orange bar represents the eBay-only content, and the pink bar represents third-party content. And here we see 2 spikes where performance was really poor. And in both of those spikes, the eBay content stayed relatively flat, while the third-party content took far longer than normal. If I were responsible for investigating the cause of the performance spikes, I would typically generate a scatter plot graph and drill down a little bit further into individual measurement results. Here you can see a scatter plot graph that plots out all the individual data points for each measurement instance. I can click on some of the worst response time instances here near the top of the graph to drill down a little bit further and get some insight into which pages were being slow, and then all the way down to a waterfall graph to see which elements are being slow. So here we can actually see on the bar graph on top that we had 4 pages in our transaction, 2 physical pages and 2 virtual pages. We started off with the eBay homepage, and then we did a search for the iPod Touch, and then we split up the search results page into 2 virtual pages containing eBay content only and third-party content. In this particular measurement instance, you can see that the eBay search page did experience that performance spike as we know, but we can also see that virtually all of the spike can be attributed to the third-party content. By drilling down into the waterfall graph associated with my third-party content virtual page, I can get insight into which page elements were actually slowing things down. This waterfall is listing out all of the individual page elements associated with my third-party content from that search results page. Scrolling down lets me see the fact that there was one page element that experienced a connection reset. Due to this connection reset, there was actually a huge slowdown as we waited for this page element to be returned to the page so the page could be considered loaded. That took over 40 seconds, which is why there was a performance spike in the overall page performance. So what we just walked through within Kite in my Keynote was an example of how virtual pages can be applied to monitor specific third-party content versus publisher-related content, and also drill down and troubleshoot performance issues when they occur. You can actually get down to the element level to determine if a particular page element is causing slowness on your site, or if it's causing availability issues because content is not being returned from either your own servers or a third-party provider. In addition to all of this, you can also define alarms and reports on virtual pages as well. That's very helpful in tracking SLA compliance for your internal teams if there is specific content being provided by different business units or by third-party content providers. You can track their performance as well and see their adherence to SLAs. So, overall, the virtual pages capability that's provided within Keynote's transaction perspective really facilitates the identification of poorly performing web page components and actually reduces the time to triage and troubleshoot performance issues.